Good morning. All right, let's go through the 752 modeling quadratics day 2. So this is just kind of a recap from Friday's modeling problems and a few more examples today talking about profit. And now profit, when you're dealing with a business, is the amount of money that you make after your expenses. So let's say you make $20,000 selling t-shirts, but the t-shirts to make them and or hire employees or overhead as we call it ends up being $10,000. Well, then your profit would only be $10,000. So it's the amount of money that you spend or that you make after your expenses. Okay, so let's go through a warm-up. It says, what value of x makes the following equation true? If you recall from Friday, we did problems like this where we're looking at a quadratic to see what the solutions are. Now, before we can do this quadratic, we have to make sure that it is set equal to 0. So we're going to subtract 5 from both sides. That's going to give you negative x squared minus 4x plus 5 equals 0. Now we can go ahead and plug this in. Minus 4x plus 5 equals 0. And you can see that the values of x that make this true are both negative 5 and 1. So our solutions here, negative 5 and 1. What is the maximum value for the equation? Well, the maximum value is, remember that it is the y value on the graph, which is 9. Okay? All right, so let's go ahead and get into some of these profit examples and see what we can do. So the profit from selling local ballet tickets depends on the ticket price. Using past receipts, the profit can be modeled by the function p equals negative 15x squared plus 600x plus 60. So let's go ahead and plug this in. You could put y equals, but you don't need to. Negative 15x squared plus 600x plus 60. Make sure it's the same. It is. Okay. And you can see that this is not all there. We know it should be a curved line because of the x squared. So if we zoom out, we finally get to our profit, which it says, what is the ticket price that gives the maximum profit? So remember that P is really our y value. So X in this case is our tickets. Okay. So our ticket price at that maximum profit is $20. It's the X value. So $20, and the maximum profit is $6,060. Okay. Problem number 2. Abdi is selling cookies to raise money for a project. If Abdi sells 230 cookies for $2.10, how much would Abdi make? So 230 times $2.10 tells us that he would make $483. Now, Abdi is thinking about increasing the cost per cookie by 30 cents. Each time he increases the cost of the cookie, the number of cookies he sells decreases by 10. Okay, so what he's saying is if he increases the cost, less people want it, right? 10 less people. However, by the increase in cost, does that increase his profit? So let's go ahead and type in this equation now. Y equals parenthesis 230 minus 10x. So that represents the price, right? So, or how many cookies? So, excuse me, 230 cookies originally, but every time there's a price increase, aka X, right? That's your price increase. It's not what the price increase is, but number of times the price increased, okay? And then 210 plus 30x is the amount that price is increasing. So it starts at $2.10, but every time he changes the price, it's going to go up by 30 cents. Okay, all right. So what is the maximum profit? $675. And how many times does he change the price to reach that maximum profit? He changes the price 8 times. It doesn't mean that the price of the cookie is 8. It means he's changing the price 8 times. So what is the price of the cookie? Well, it starts at $2.10, but then he changes the price 8 times, and each time it's worth 30 cents. So that ends up being $2.10 plus 30 cents times 8 is $2.40. So the price of the cookies ends up being $4.50 to make the most profit. Now, obviously that means he's going to sell less cookies, right? How many cookies did Abdi sell to make a maximum profit? He's going to sell less cookies, and it's not going to be 230 anymore. But he makes more money because of the price increase. So 230 minus 10 times 8, which is 80. So 230 minus 80 is 150. So 150 cookies is how many he sells. So he ends up making himself a little bit more money and making less cookies. That sounds like a good deal to me. Okay. An auditorium has seats for 1,200 people and has been selling out every night. So tickets currently cost $5, and the owner wants to increase the ticket prices. He estimates that for each 50-cent price increase, 60 fewer people will buy tickets. All right, so same type of problem, right? You got an original price, and we're looking for the maximum profit as a business person. All right, so we've got 1,200 minus 60x. Then we've got $5 plus 0.50x. So, okay. So what is the maximum profit? Let me just make sure. Yep, it's typed in correctly. Okay, the maximum profit for this auditorium is $6,750. What is the ticket price that will maximize that profit? Ooh, be careful here. So 5 is not the ticket price. That would be 5 increases, which means that the new ticket price, if you recall, was originally $5. So it'd be 5 plus 0.50 times 5 increases, right? Because this is the price. This one is the number of tickets sold. Okay, so 5 plus 250, is $7.50. So $7.50 per ticket. And how many tickets are sold? Well, that's the second one. So 1,200 tickets originally minus 60 times 5 price changes. Now, 60 times 5 is 300, so we really just have 1,200 minus 300. So that tells you that they only sell 900 tickets. Okay, so now there's some seating available in the auditorium, but they're making the maximum profit. Whereas originally, no price changes, they made $6,000. So now they're making a profit of $750 more by increasing the price. Okay, sorry about that. A bus company charges 50 cents for a one-way fare between Morse Road and High Street. The owners researched the effect of increasing the price 10 cents of the one-way fare. The following graph represents the information they found from the research, where Y is the profit and X is the number of times the price changes. Use the graph to fill in the blanks. So the company currently transports how many passengers per day? Well, remember that it's what it starts at, right? Currently means starting. Which, as we know, the starting point of any graph is at the y-axis. So it currently transports 175, right here, passengers per day. This is given by the, well, where is that? It's the y-intercept. Since the graph has a maximum value at x equals 1, right? It's at, so that's the where. The company will earn a maximum profit of, this is the what. Remember, we talked about when and what. Maximum profit of $180. If it sells tickets for 1 is the price change, okay? So if it was originally 50 cents and it adds 10 cents every time you increase the price, and there's only 1, that means it's going to be 60 cents. It's going to be 0.50 plus 0.10 times 1 because there's only 1 price change. Okay? So I hope this helps you understand just the very basics of looking at profit when you're dealing with quadratics. This is one of the applications. But you want to maximize your profit as a business owner, right? And sometimes that means not necessarily selling out in terms of, the number of tickets or the number of seats, but rather maximizing it from the price of the tickets. And there's a lot more of this if you take business class, so I would highly recommend that, get you some better feedback or economics. But for now, go ahead and complete your exit ticket, which is the Canvas quiz, 752. 2. And I will see you guys soon.